So this is my video on exponential and logarithmic models. We will not be doing too many. There are a lot of exponential and logarithmic models. And for example, the virus spread right now the world is experiencing also can be modeled using a certain type of exponential model. We'll be doing some basic models. So first of all, let's talk about compound interest. Now, before you understand compound interest, you need to understand what simple interest is. So, if you say put $100 in an account and you put 10% simple interest, right? Suppose you want to find the balance after 1 year. So $100 and then the balance would be $100 plus interest. And what's the interest? It's 100 times 10% is 0.01. So 100 times 0.01 would be the interest plus $100. That will be the balance. So 100 plus 100 times 0.01 is 10. So 100 plus 10 is $110. So the balance is $110 if you use simple interest. Now, suppose you use compound interest. So what's going to happen? So we are going to put, say, $100 today and the same interest rate is 10%, but we will compound it twice in a year. And you want to find the balance. So what do you mean by compounding it twice a year? So twice a year means we take a break once every 6 months. So twice a year means, so here's what you do. So you put the $100. After 6 months, you calculate interest. Okay, so what's the interest after 6 months? It's $100 times, it's not 10% because 10% is for 1 year. So for 6 months, it will be 5%. So you multiply by 0.05. So $100 times 0.05. So the interest after 6 months this is just 5. So it's $5. So now what happens is you have originally $100. You add $5 interest after 6 months. So you get $105. So the $105 becomes your new principal for the last 6 months. For the next 6 months, right? Then you put $105 and you calculate interest on the $105. Again, it's 5% because we are only looking at the last 6 months now, 6 more months. So it's 105 times 0.05, which is 5.25. So again, we put $100 at the very beginning and we calculated interest after 6 months by multiplying by by 0.05. And then we added that to the capital and we get 105. And that 105 is the principal, the new principal for the last 6 months. So to calculate interest on that, we multiply that by 0.05, right? And we get 5.25. And so the balance would be the principal now is not 100 but 105. You add 5.25 to that and you get 110.25. And that is your balance after 1 year. And that is in dollars. Okay, $100, $110. Of course, this is a ridiculous interest rate. Nobody gives you 10% interest, right? But this is just a mathematical problem just to make things easier. Now, this thing can be modeled by an equation, and this is called the compound interest equation. So if you want to find the balance is given by A, which means in finance, the word amount means the balance. P is the principal, which will be the $100 that we put in this problem. 1 plus what is R? R is the interest rate, the annual interest rate. So that will be the point zero 0.01 because point 0.1 because we put 10% interest, right? So that will be point 0.1. And then N is actually the number of compounding intervals per year. It's very important that you understand that N is per year. So if you are doing it twice a year, that means you compound N will be 2. So N will be 2 in the previous case. For example, if you're compounding monthly, then you're compounding 12 times a year, then N will be 12. If you are compounding quarterly, then you are compounding 4 times a year, N will be 4, and so on and so forth. And on top you have again n, which is again the number of compounding intervals. T is the number of years. So plug in that, all that, and A gives the principal. Suppose you want to use this for the previous problem, then P will be 100, right? Because we are putting $100. 1 plus R will be 10%, which will be zero point 0.1. So 100 times 1 plus zero point 0.1 divided by 2. So 100 times 1 plus zero point 0.1 divided by 2 to the power, what is n? N is 2 and then t is 1. So then 2 is 1. And then if you use your calculators and calculate this, right? Okay. And then this actually becomes 1.05. And so it's 1.05 to the power 2 times 100, right? And that turns out to be 110.25. So if you compare the two interests, the balances, simple interest, actually in this case, right? Okay. So we got the same answer. as we did a manual calculation 110.25, but do compare that with the simple interest, right, which is 110. So this is better than the simple interest, right? Okay. So the same manual calculation, now you can use the formula to do it. Okay. So let's do another very quick example. So the same problem I want to do. Suppose the capital is the principal is 500, and suppose the interest rate is 5%, and you want to find the balance after 2 years, and suppose you are compounding monthly. So 500 means P is 500, right? So what is 5% means R is point zero 0.05 now, right? Okay, and compounding monthly means N is 12, right? And we want the balance after 2 years, so t is 2. So if you plug those in that equation, you get, if you go back to the equation, you get 500 times 1 plus 0.05 divided by 12 times 12 times 2. Okay, so that's what we get. 1 plus zero point zero 0.05 over 12 times 12 plus 12 times 2 is 24, right? Okay. So, and then when you use a calculator and calculate that, you get 552.47, which is the balance after 2 years. So that's how you do a simple, straightforward compound interest problem. Now, sometimes they might actually give you the amount and ask you for the principal, in which case, you just plug in the amount here and then you plug in everything else and you solve the equation for the principal and you get the principal. Now, a different type of the better, so you can compound. So we saw compounding every 6 months in the first problem, and in the second problem we saw compounding every month. That means 12 times a year. You can compound even daily. You can compound even every hour or every second. So sometimes, in most financial institutions nowadays use continuous compounding. So when you compound it continuously, you're not compounding twice a year or for monthly. You're always every millisecond, every you're continuously compounding, and then the equation changes. Then the amount is equal to the principal times e to the R is the interest rate again, T is the number of years. So let's do a simple example. Suppose you put $100 is invested at 10% interest rate, now compounded continuously. You want to find the balance after 1 year. The same problem as we did before, but now the interest is compounded in continuously. So what you do is you put P would be what? P would be 100, right? And E to the R would be zero point zero 0.01, sorry, point 1 because you're doing 10%, right? Okay, so zero point 0.1, okay, times number of years would be 1, right? Because you want the balance after 1 year, right? So when you use this formula, so 100 times e to the zero point 0.1 times 1, if you calculate, do that, you get 110.52. So if you compare with even slightly even better than the compounding twice a year, much better than compounding, not compounding at all, like simple interest. So simple is 100 and twice a year 110.25. And now if you do it continuously, you get 110.52. Okay. So that's uh, those are the examples. So let's do a different type of problem. So now suppose you have $100 invested at 10% interest rate compounded continuously. Found out how long it will take for the money to double. Now here they are not asking for the amount. You already know what the balance is. What's the balance? So $100 invested and you compound it continuously. You want the money to double, so you know the balance. What's the balance? The balance is $200. So what you do is we all go back here and we plug in 200 here. So 200 is the amount. What's P? That's $100. And E to the what is R? R we know it will be point 1, right? Because it's 10%. So what is that you don't know? You don't know the time. So really you want to find the time for the money to become 200. So this is the same type of problem you can ask, like you want to find the time for the number of infected from a virus to reach a certain amount, or you want to find the time how long ago did a dinosaur lived by carbon dating. The same type of problem, right? I mean, whenever you want to find the time, you want to solve an exponential equation. So let's do it now. So A is what? 200, P is 100, E to the point 1 times t. So 200 is equal to 100 times e to the point 1 times t. So if you divide by 200, right? Okay, then you get 2 is equal to and then you have 2 is equal to e to the point 1 t is equal to 2. Now this is an exponential equation, right? So all I did was divide the 200 by 100. So I isolated the exponential. When I isolate the exponential, I get e to the point 1 t is equal to 200 divided by 100 is 2. Now exponential equation, how do you solve this? You take the natural log on both sides. So you direct the natural log on this side, you get natural log of e to the point 1 t. If you take the natural log of 2, you get natural log of 2. But we know that the natural log and the exponential will cancel off and point 1, and you get just point 1 t on the left hand side, and that will be equal to natural log of t. So you solve for t and you get t is equal to natural log of 2 divided by zero point 0.1, and that will give you 6.93 years. So really it takes 6.93. If you have a 10% interest rate, which is a very high interest rate, you can double the money in 6.93 years. So let's do one more type of model. So we did compound interest, which is an application of exponential equations, right? Continuous to compounding and compound. Let's do quite a lot of things like population and even continuously compounding. They grow using exponential. Bacteria grows exponential growth models, and sometimes viruses, number of infected from viruses at certain points become exponential, not always, right? And so we have two models. The growth model is y equals a times e to the bx, just like what we saw here, right? Something times e to the rt, so e to the bx, right? And the exponential decay is a times e to the only thing is negative bx. You know that the graph of this will be a decay graph. The graph of this will be an increasing graph, and we already did that in 5.1. So let's do a problem. This is a kind of a challenging problem, but I think the book really wants this as a starting problem. So let's do it, okay? So a research experiment, population of fruit flies is increasing according to the laws of exponential growth. So after 2 days, there are 100 flies, and 4 days, there are 300 flies. How many flies will be there after 5 days? So you start with the equation. Now, in this equation, A is actually the initial population. Unfortunately, in this problem, you don't know how many how many flies you started with. You need to find that also. All you need is that after 2 days, you have 100 flies. So here we do not know anything. We don't know what A and we don't know what K is. So the first thing to do would be to find the constants A and K. So let's try to find K first, which is actually kind of the easier one to start with. So first of all, you put the data. So first data would be what? After 2 days, 100 flies. So when y is equal to 100, t is equal to 2. Okay, so then we put 2 here. So you get 2 times k, a times e to the 2k, y is actually 100. Okay, so I is equal to 100. That's your first equation. This is my first equation, right? Okay, I can call it my first equation, right? Okay. So that's my first equation, right? And now I can get another equation from the second piece of data, but means after 4 days, there are 300 flies. So I put in y 300, 300 is equal to a is still constant, e times, now k is a constant still, but t now is 4 because we are talking about 4 days. So e to the 4k times a is equal to 300. That's my second equation. So I need to now get rid of, solve these two equations and try to find a and k. So the best way to do this would be if you divide the first equation from the second equation, right? Okay, then you have 300. If you divide the left side, you get 300 divided by 100. If you divide the right hand side, you get this chunk divided by that. So a times e to the 4k divided by a times e to the 2k. And then a's will cancel off, and you have e to the 4k divided by e to the 2k, right? Okay, but when you divide exponents, we know that you subtract exponents. So really, the a's will cancel off, but you get e to the 2k. And on this side, you just get 3. So you get e to the 2k equals 3. And we know that this is an exponential equation. We can solve it to find k. How do you do that? You take the natural log on both sides. So natural log of e to the 2k is equal to natural log of 3. So here the natural log and the e cancel off, giving you 2k is equal to natural log of 3. So k is equal to natural log of 3 over 2. And then that is 0.54. So we found one of them. But before we do anything, we need to find a also, okay? So how do you find a? Now we can take that, go to the first equation, we can plug in for k, that value that we got, And let's see what we get. We get 100 equals 100. Is this 100? A times e to the 2. And what is k now? K we know to be equal to 0.5493. So when you plug that in, you get 100 is equal to a times e 2 times 0.5493. If you use your calculators, this turns out to be 2.99996 times a. And if you solve for a, you get a is equal to 100 divided by 2.999, which is 33.34. So very good. We found a also. Now we can actually write down the equation. We know what k is and we know what a is. So y is equal to 33.34 is this times e to the 0.5493 times k. So that's your equation. So we write the equation now. There are no constants, only the t is there. So we found this one and we found that is your a and we found the k and we write the equation. Now, only now we can answer the question. What is the question that they're asking? How many flies will be there after 5 days? So remember, you can answer the question only after you find a and k and write the equation with numbers plugged in for a and k. And that is the equation now. Now we can easily find it after 5 days. All you need to do is to put t equals 5, and then when you put t equals 5 like that, and then you get 33.34 e to the 0.5493 times 5. Use your calculators, you get this, and that is 520. And basically, that's the answer. That is the amount of price that you will have after 5 days. So now that you got the equation right, okay, you can solve any question that you want. For example, if I ask you how long will it take for the number of flies to become 10 times the original, then all I need to do is to put y or say 1,000 flies. So what I need to do is to put 1,000 here and then I want to solve for t, right? So you get an exponential equation, divide by 33.34 and take the natural log on both sides and solve for t. So once you get the equation, you can do anything. Thank you very much for watching.